Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
Good afternoon, all. I hope you all doing. We'll start the session for the day. Aripsa, good afternoon. Aripsa, are you there? Is my voice audible?
Hi, Sushmita. Hi, everyone. Good afternoon. Welcome back. All right. Welcome back. Firstly, yeah, hope you all can hear me. Thanks again for joining. Yeah, we will get started in a minute. Let me just share the screen and get those things right. Yeah. Okay. Yeah. So a quick recap on what we did yesterday. I think I'll also just share my screen. Yeah. So day one, we started out with Agentic AI, what is an intro to artificial intelligence, the entire AI landscape, right? The fundamentals of generative AI as well. Right? So we started out with all of those things. Then, in terms of the fundamentals, right? So we discussed the evolution coming in from machine learning, the entire AI landscape, right? So what are the foundations, right? So all of those uh, things were sort of that. Okay. Yeah. So we started out with what is AI? What is the AI landscape? Right? What are the fundamentals of Gen AI? Right? Further, we saw the entire AI life cycle, certain definitions, modalities, saying text to text, text to image, all of those different modalities. Right? Then we went into a deep dive for what are LLMs and how we can work around with LLMs. Yeah. We also discussed the types of LLMs, closed source or open source LLMs, the entire model ecosystem of the LLMs. What are the examples? Then we further saw what are tokens, right? We saw what is a context window, what is the limit that is there, a few basic prompts and the prompt structure or the formula. Right, then for a comparison, right, we saw what is Gen AI versus Agentic AI, and we were seeing a little bit towards what is Gen AI, what is Agentic AI, and we saw just a little bit about the workflow. Yeah. Did we see anything about LangChain as a tool? Say, what is LangChain? LangChain as a tool? Yes. We spoke about the LLMs. Did we do any LLM invoke yet? I don't think so. Yeah. Okay. Let me just go here. Okay. What was the last thing we stopped at? Meanwhile, let me share my screen. Tokens. Okay. Running through the slides, right? I think we discussed about prompt and prompt formulas as to how exactly the prompts look like. Yeah, what is the best way to define the prompt, right? In terms of the key components. Yeah. Yeah, a lot of you had requested for the presentation and the material as well, right? So it should be uploaded on the LMS portal. Not yet, a little later, right? It has been shared and we are in the process of uploading it as a PDF document for your reference. Okay. I think also the recording, you might be getting that to view. Okay. Now we discussed about the prompt formula and the 5 key components that should be defined within a particular prompt is what we had discussed. So this slide, yes, we did. We had discussed this. Yeah. What are 5 essential prompt components which are available? Okay. All right. So today what we'll do is, yeah, I think Gen AI versus Agentic AI, a simple comparison was also done. It's a bit started out with a simple comparison for generative AI versus Agentic AI, right? As in that Agentic AI is something which achieves goals, right? Which is goal directed, which solves problems. Yeah. So the evolution of AI, how did it reach generative AI was the question, right? And what we could just see was earlier it was just logic. It was just rule based automation based on logic, based on rules, based on if else conditions. Yeah. Then we slowly evolved to machine learning based solutions, right? Then to Gen AI based solutions where new content was generated. Now we are at the level of agentic AI, which is a goal driven action, right? So this is where we actually are in the current space. Okay. So agentic AI refers to systems which are intelligently designed to set goals, plan, execute, and it is almost like expected to run through workflows, right? So it is expected to run through multiple workflows, right? What exactly these workflows can do, right? So these workflows are actually going to go ahead, perform a certain set of executions, and then give you the responses. Okay. So if you compare the three hype terms, Gen AI, Agentic AI, and what is AI agents, right? A lot of times we are going to interchangeably use Gen AI, Agentic AI, AI agents. Okay, so even if you keep aside Gen AI, we know it is just about creating new content. But Agentic AI and AI agents are pretty similar. So Agentic AI is something which performs tasks autonomously and you can get goals. Whereas AI agents combine the abilities, and these are actual tools or actual resources that are there. Agentic AI can be like a technology. AI agents is a software, or it is like a tool which is ready, or it is like an app or like a bot which is going to do all of the agentic AI work. So AI agents combine Gen AI for its generative capabilities and agentic AI for its agentic capabilities to accomplish all of the required objectives. Okay. Now, when you look at the agentic AI in the workflow, yeah, what happens in the agentic AI workflow? And so just look at it. You have some input that is taken. For a workflow creation and generation, right, you can see earlier there should be some kind of understanding, some kind of interpretation and reasoning. So one of the agents that we'll be building further is called as a reasoning and action agent, right? So the name itself says React agent, which is a reasoning based agent. Okay. So in this workflow, you take the input from natural language, you have some reasoning done, and based on that reasoning some action will be done, and further it will help you create a workflow. Now the workflow will be generated, and once the workflow is generated it will be executed, and finally you get the outcome. Okay, finally you are going to get the output or the outcome. Okay, what is the difference between reinforcement learning and agentic AI? Okay, so when you speak about reinforcement learning, right, what do you mean by reinforcement? Backups? Yeah, what's reinforcement? When you have some military operation or a police force, right, what do you understand by the term reinforcement? Right, so just the literal meaning of reinforcement is what? Sort of like a backup in the army, navy, something like that. Or it can be making something smarter, stronger based on previous feedback. Yeah, two senses or two meanings. Yeah, so you want to make something bigger, better, stronger, faster, right? So that can be a reinforcement. Yeah, also in the example of police forces or army, right, so reinforce means backup. I need reinforcements, right? So I have backup. Or anywhere, any stock, right? So they speak about, right? So you have something that you're creating and you are running low on your quantity, again reinforcement. But what is reinforcement in machine learning? It's a type of ML, right, wherein you have an agent which will learn to make decisions by performing actions, or learning is happening here by softwares to make decisions based on feedback. Yeah, when you speak about reinforcement learning, so it trains softwares to make decisions such that you get best results. Okay, so reinforcement learning is something where it learns from feedback of each action, and then you get outcomes. Processing will happen, right? So the algorithms will be there, and then based on the feedback it will be retrained, it will be what do you say, trained again and again based on various parameters, and then you get good, excellent answers. Okay, so reinforcement algorithms are generally used in some complex environments. Yeah, now if you take the general ML algorithms, we have to specify all of the parameters. We have to labels. But when you take a reinforcement learning algorithm, right, so you don't have to label data, you don't have to manually do work. It learns by itself, right? Plus, it has that human feedback integration system which will be there. That's one advantage. Okay. Now, when you take a agentic AI, in agentic AI, what will happen? Reinforcement is metaphorical. In reinforcement learning, reinforcement is literal. It has to do some reinforcement. In both cases, you can use agents. There is a feedback loop in the reinforcement learning also, which is why whenever you speak about agentic AI, anyways, slightly you are always oriented towards reinforcement learning as well. Yeah, because in reinforcement learning, RL, reinforcement occurs through feedback signals. In agentic AI, reinforcement happens to automated or augmented intelligence systems. Okay, so it makes AI smarter. It makes your agents smarter. Okay, understanding? So in agentic AI, right, or for with AI agents, right, so your reinforcements is something which is going to add more capabilities to the AI agent. It uses reasoning, planning, memory, tool usage. All of that thing will be added extra to the AI agent when you speak about reinforcement in agentic AI. Okay. Now, for our topic for today, right? So we were supposed to start with what is LangChain as a framework, right? And how we can integrate or create a RAG-based system using LangChain. Okay. Now, what exactly is LangChain? Anyone heard of it? Like I told you, we'll start with a little bit of coding as well today. Because the moment we speak about agentic AI or MCP or A2A or any kind of enterprise agent, right? So we are dealing with some kind of a open-ended open source framework. Yeah. So LangChain is that framework that we'll be using. LangChain has many capabilities, also pretty much what we would need to build an AI agent, to build an enterprise level AI agent, right? So I can be using a framework for LangChain because firstly, it allows me to integrate LLMs. The most important thing for agentic AI framework is that we need LLMs. So LangChain provides us with LLMs capability, right? So we can see LLMs, we can use LLMs within LangChain. Okay. Then when we speak about LLMs, right? So there are other things that we need along with an LLM. How to put in prompts, right? So we need prompts, right? So we need it to allow us to put in prompts, allow us to use prompts. Okay. So then it supports prompts, it supports a chat template. It allows us to build chains. Now, chains is something that we use for a rack system, right? LangChain has got something called as chains. It has its name from chains. Yeah. A rack chain is what we specifically can build. There are other capabilities. It can load documents. It can store data or vectors in a vector database. It can also help us to build agents. So it has the agent capabilities as well. Okay. So that's what LangChain does. These are some of its capabilities. Yep. I will be referring to the documentation to show you how exactly all of the entire framework works. I'll give you the links. You can also refer. Okay. Now it's an open source framework. Firstly, it'll let you build applications. Right? It'll let you build applications. It'll let you build tools using LLMs. Now, when you use LLMs in here, right? When you use LLMs, right? So you can see that within an LLM, LangChain allows you to integrate that, get that LLM within LangChain, connect that with external data, external tools, or any kind of workflows. Now it gives you that platform. It gives you the open source framework, says that you can just deploy your AI agents, right, in real time into production. Okay. Now see, there are two things. You know what's an API call? API call, what is it going to do? API stands for Application Programming Interface. Now, if I take one LLM, which could be a example for LLM is GPT, Gemini, right? It can be Grok, ChatGPT has its own LLM, Gemini has it, Grok has it, Claude has it. All of the models and all of the names that we were speaking about, all of those are LLMs. Okay. Now, when you look at LLM, if I do a LLM simple API call, right? So with an LLM, I can extract just by using an API, I can ask some question, right? It can just be a LLM invoke, a simple LLM invoke. But if I use LangChain as a framework, the same API can be used. Instead, you have a orchestrated workflow created, because then you connect the LLM via the API to various tools, to chains, to agents also. Make sense? So if you use it via LangChain, right, you are having access to tools, you are having access to chains, to agents, all three together with a well-orchestrated framework and a well-orchestrated workflow. One sec. What happened? Okay, all right. Yes, you can use Perplexity. Perplexity, I think, has Sonar as its LLM. Yeah, good afternoon. Okay. Now coming to the example on the right side, how API integrations with LangChain work. Suppose I am a client, I send a request using the API. Okay. Here, you can see I send a request using the API. From here, I am having a request to the server. Now the server is going to send that query to ChatGPT's API. Now from the API, the moment it is accessed, it will return a response. Give it to the server, server will give the response to the client, which is me. Okay. So I ask a question, it will access the API, give the answer, come back to me. Okay. That's how we actually get a API integration within LangChain and how we could actually get some results from an LLM. Okay. Yeah. Hugging Face has a lot of LLMs. Yes, you can connect a few of them with LangChain, right? But those are Hugging Face models. Yes. Okay. Like example, this is what I wanted to show. So you take all of these LLMs, any of these LLMs. From Hugging Face, there are some models. Gemini has some models. Anthropic has some Claude-based models. OpenAI has some GPT-based models. Cohere has some models. You take all of that, you use it with LangChain, which is having a unified LLM-based interface. Okay. So it'll help you build a chatbot, a workflow, an agent, a RAG system, a Q&A system, all sorts of things. It's now available within this. Okay. I hope this is clear. Now, we'll just see some of its components, right? So we've just seen in brief what all things were available in LangChain. Yes, how about DeepSeek? DeepSeek is available, right? So you can include DeepSeek here. It is yet another LLM. Quen is another LLM. Yeah. So So you could be using any of those models. Right, so we'll go on to the LangChain website documentation to see what all integrations, what all LLM models are available within LangChain that we can use. Yeah, we'll have a look at that next slide after this. Yeah, I'll show you, Preeti, about that as well. Is Perplexity available? Can we use Perplexity with LangChain? Can we use Hugging Face? Right, I'll show you all of those things. Okay. Model and LLM are same. See, LLM itself stands for large language model. Yeah. So LLM itself stands for large language models. In some places, like example, within LangChain you go, you wouldn't find the term LLM. It will say models. But everywhere else, we are going to discuss it as a large language model. We don't necessarily call it as a model because in other terms outside of GenAI and Agentic AI, a model can also be there for a deep learning based model, a machine learning based model. But if you're speaking in terms of agents and GenAI only, then model and LLM is same. See, like LangChain's component does not call it as LLM, it calls it as models. What are the foundational models? This equal to LLM. Okay, correct. Within Claude, you have different models. Within GPT, right? Within like Chat GPT, again, you have different models. Within Hugging Face, you have different models. Within probably even Gemini, you have different models. All of those models can be different LLM models. They are all LLM models. Yeah, so it's the same. From a perspective of what? From a perspective of Gen AI, Agentic AI, yes, it is same. Okay. Now, if you look at the other components, I have a model, prompt. There are some system-based prompts. Right? Then there are chains, which will link multiple models. Yeah. Then there is memory. So you can have a save it as a memory. Okay. Memory-based agents. So you have a database that you can connect. You have a vector database, in fact, that we connect. Indexes, right, which sort of comes as part of your RAG based system, and then agents. So you can build a separate agent. So there is an agent based module as well. Okay, these are some of the core components which are there within LangChain. Yeah, and like I said, I'm gonna show you. Hold on. Let me just share the screen. Let me just open LangChain and we will go to the documentation of LangChain and then I will show you all of the available options in there. Okay, so this is LangChain framework. See, yeah, we will be creating practically a LangChain RAG framework today, a RAG based agent, tomorrow a AI agent. Yep. And then after that we will go to multi-step or multi-architecture agents, right? So not just a single agent. Tomorrow we'll see a React based agent, then we'll go to the enterprise AI agent for multi-step or multi-architecture agents, and then go to MCPs as well. And we will also see a automation platform with a no code low code framework, which is N8N. Yeah. So some amount of coding based examples, a couple of demonstrations for no code platforms as well, where if you do not want to do it with the Python and the code, right, how to build automation workflows without codes, right, so I'll show you that as well. Okay, now this is the LangChain framework. Okay, in terms of building, right, so I think I can just go directly to agents, LangChain, LangSmith, right? So we have all of these things. Now, you can just see there are so many products in here. Okay. So I just go to open source frameworks. So you see there is LangChain, LangGraph, deep agents. Yeah. So I am just going to go to the documentation of LangChain. So from this, just go to the documentation of LangChain. Okay. And then you can just see here, there is a complete documentation available for LangChain, LangSmith, deep agents, LangGraph, every single thing. So I'm going to go with this link for a quick start to LangChain, which gives me the entire documentation reference. So this is one link that I would want you all to keep it available with you for every time. Yeah. So you can directly come up to this link. Yeah. Yes, we will be building our own agents. Mega, regarding the LMS, maybe you can just check with the support team once. They should be able to guide you with the exact links. Yeah. Also, Bushra, so regarding the chains, right? So chains are what? Not LLM models. These are the workflows. These are step-by-step workflows, which will combine multiple components together, like LLM plus prompt template plus any other tool, all of that, defining it into a single workflow. It is called as a chain. Like example, for a rack system, we are going to be building a rack chain. Okay, that's how it goes. For a rack system, we are going to be building a rack chain where we will use LLM. We will use some external files, some tools, which will link to the LLM. We will combine all of that by using a chain. Understood? All right. So if you see the documentation here, right? So please, you all can just start from this link. I've shared the link in the chat. This is where we have a start with the link, how to build a fully functional AI agent, right? So in fact, there is an entire step installation, get started. You can build everything just by referring to this. Yeah. So we are looking at an open source agent, right? So you have LangSmith, you have open source LangChain. You can also use LangGraph and deep agents for much more advanced ones. So we will be touching upon this majorly. Later on, we'll also be touching upon a little bit of LangGraph as well. And we will go to all of the integrations available, because mainly with LangChain and LangGraph, all of the integrations are the major source. Okay, it's mainly all of your integrations that are available. Okay, now when we look at the documentation, right? So how do we install this? How do we install LangGraph is the first thing. So you have a pip install that you're supposed to do. So dependencies wise, pip install LangChain is what you do. Look at this, just use a pip install LangChain. Now suppose I want to connect the models, which are my LLMs. What are the options? So go into LangChain. In the documentation, in its core components, we saw, right, agents, models, tools, memory, streaming, all of that was available. So there's middleware, front end, advanced usage. Here comes MCP, human in the loop, multi-agent, right? All of these things are actually going to be available, right? So here, what do? We go to models to see a list of all of the models which are available. Yeah. And what do you find? Right. What do you find here in terms of your LLM models? Right. LLM models say that. Okay. So first it explains what are LLMs: AI tools which can understand, interpret, and generate text like humans. Okay. It can do a lot of its own work. Now, addition to text generations, many models support a few of these options. Okay. Now, where do we use models? See, right now, the moment you say models, it is understanding that it is LLM, large language model, and model is same in the context of AI agent. That is a basic understanding for us. Let's say models are reasoning engine of agents. We are going to build an AI agent which has LLM model as its reasoning engine, right? So we will create a reasoning agent called as a React agent. Okay. Now let me just scroll down. Models can be used as a standalone, as an LLM individually, or a model can be used along with creating an AI agent. So there are two ways to use that. So maybe I want to use Gemini or Claude or anything for that matter. I can use it as just an LLM. Okay. Or I can use it within a AI agent as well. Because even an AI agent needs a LLM within it. Okay. Now, how to initialize a model? What model are you looking at? OpenAI. OpenAI has got different models. For example, GPT 5.4. Okay. OpenAI GPT 5.4. Anthropic has got Claude, but within Claude, Claude Sonnet, Claude Opus, different options. Azure has got its own model, Azure OpenAI development deployment name. Okay. Again, Azure also uses a model of GPT 5.4. Okay. Gemini has got 2.5 Flash as its LLM model. AWS Bedrock has Claude Sonnet 3.4 that it uses, but different version of it, optimized version for AWS. Hugging Face has got a lot of models. So in this case, they've used a Microsoft V3 Mini. Now this can totally change, right? So I can go on to Hugging Face website and then show you there are so many different models that are available to use. There's Quen, there is DeepSeek, there is Meta's Llama, there is Microsoft V, so many options. There is Mistral. All of these are the models which come under Hugging Face. So example, you can just see here. What are the models and the references should actually be given here. Okay. Okay, Rajesh, I think it's available for anybody to join. There's not necessarily any log or anything. Please check. Retry, you should be able to log in. Okay. Now just going to the Hugging Face integration models. Do we have the list of models? No. Okay. Sushmita, if you can please check regarding the meeting, it says it's logged.
Yeah, yes, sir. I have unlocked it.
Sure. Okay, this says you must set up a login. Right? I had one sample account. Okay, anyways, look at the models which Hugging Face has. It has Google's Gamma. Yep. NVIDIA's models are available. Right? So it has here, if I keep scrolling down, NVIDIA, it has got JetBrains thinking model. Right. So Google has got various models, Magenta, Gamma, right? So DeepSeek, Cosmos, right? Some of the models which are available. Meta has got Llama, Sulfur are some of the list of models which are available within this. Okay. So within Hugging Face, these are the options that we have. Now, let me go to something else. So there's I think Open Router as another integration that is shown. Okay. So these are some of the examples that they have shown within the models and that can connect to LangChain. Okay. Now speaking about Any other models that we have missed here? Yeah. Yeah, within LangChain, right? So you can just see about Perplexity, right? Perplexity has got a chat Perplexity model for a Sonar and a Sonar Pro. LangChain has got Perplexity model for Sonar. I think directly it has not been mentioned here, but Sonar model works. See, it has got a lot of other lists. So I think Perplexity sort of comes in within this list. Okay. So chat models, popular providers, Olama is there, AWS, Databricks, Chroma, the one I was speaking to you about, Grok. Right. So Grok is also available here. MongoDB, Mistral, Cohere, Tavily, DeepSeek are all available. Perplexity. Yeah, Google, Docklink. So many options are available here in the Python LangChain based integrations for the providers. Okay. Now, what are the main things that it can do? It can invoke. Invoke is ask a question to the LLM, get an answer. Okay. Now, model takes messages as inputs and output messages, and it gives you a response. You can also stream as well as batch send the request. So you invoke, but the output is stream as it is generated in real time. So whenever it gets the output, it will give you the response. Batch is sending multiple requests in a batch for much efficient processing. Okay, these are some of its features. Okay, now generally what we require for initializing and using a model with LangChain is name of the model, like example here, Claude Sonnet, right? It needs the API key, and then temperature, max token, max retries are optional options. Okay? So we'll see. Where can you actually go ahead and code this? Right. So I like to use a collab scratchpad. This is where I go. This is where I go ahead and use, or you can actually set up a Google Drive link, right, wherein you just go to collaboratory, right? So you can use your own versions like a Visual Studio Code, right? You could also use Google Colab. You could also use any other editor, not an issue, right? Now see, if you just want it to work quickly within an instant without any installation issues, right? So best bet, use it on Collab, right? But if you are looking at deploying something on the cloud, right? Or if you're looking at creating a web app out of it, a suggested thing would be go to a VS Code or a similar interface. Understanding that? So Collab works. But if you want to build an app, Collab is not a that good of an option, because once you take the app will be deployed locally. So the moment any app gets deployed locally, Collab does not seem to be the best option to use. Okay. Now I have two options. I can use Collab or I can use a Visual Studio Code. Right. But if you use Visual Studio Code, you need to understand about your dependencies. You need to understand about your libraries and everything that you install. It needs to be in the right structure. Yeah. Else, if you feel all of those things are not set up correctly, you can immediately go to Collab. So I just go to Collab Scratchpad. Okay. Yeah. So is there anything that I can show with a poll? Can I create a poll or something? Yes, polar quizzes. Hold on. Okay, now I wanted a poll to ask how many of you have VS Code? Just give a thumbs up in the chat to this. How many of you have a VS Code IPYNB notebook option, which is basically this? Let me share that on the screen. Because if you want to practice along or code along, and maybe you want the codes, right? So then probably you need to have this, right? I'm going to demonstrate and show you. I'm just saying, just in case someone wants to type along. Okay. See, you can always go ahead and try setting it up though. What I would expect is this. On a VS Code, you should have at least a print of hello world gonna work. And so this should be working if you are on a VS Code because it needs the kernel and the environment. And so that makes it difficult because there will be different dependencies. I'm not sure about this as well. What dependencies? Look, I'm just using the global environment. So in future, if I have to install anything, like example, a pip install, yeah, Streamlit is one thing that I need. This is the precise reason why we need VS Code, because this is one app building uh, library or a framework within Python. So if it can install Streamlit and if you can get a Streamlit running, then we're good. You can use VS Code. Now you see, since I'm on a Mac, it expects me to put a pip3. On Windows, it expects you to put a pip. Okay. Now these are some dependency issues, right? So that you might have if you're installing VS Code. Okay. Now, if you want to not get into this too much, just bypass all of this. You just want the app to be built. Yeah. You just want the coding and everything to be done where you ask a question in the notebook interface itself. Feel free to use Collab. Right? That's why I'm giving you two directions. If you want the app building, right? If you want to deploy it, you want a UI with a proper app, right? So then you need to have something like a VS Code installed locally on your system. But initially, if you just want it to run with the questions and you're seeking answers, then we are good to use Collab. Okay. Now, now the easier option for all of us is to use Collab because not everyone is having, I'm not expecting everyone to have VS Code installed, right? But Collab is very easy to set up. All you need to do is just go to collab.research.google.com. I can give you a link. So you want to start typing, you can type along and it won't cause any kind of dependency issues. I have given you a link in the chat. Yeah. So this will not cause any kind of dependency issues. Because whatever I install will be exactly the same for whatever you do. Okay. So here's what I'll do. I'm going to set up a Collab notebook. Let me first go to VS Code. I think this got installed. See, I need this much. If you are running on VS Code, this should be installed. And maybe if I just give something like a Streamlit hello, it should run. It should not throw any error. So this means your setup will be complete. We'll have a look at it later. I'm anyways going to come back and then I will anyways be seeing this. Right? If this is done, if this is ready, then you have your VS Code setup done and it is working. So it should say, welcome to Streamlit. Okay. Now, like I said, I'm going to switch back to Collab because this is what all of us have access to. So we will go to Collab. Okay. So this is Google Collaboratory. I've given you the link in the chat. Anyone wishing to type along can definitely type here. Okay. So we'll have a cross check again. Print of hello world just to see if this Python code works or not. Yeah, this gives you a hello world option. Returns you with a hello world. Yes. Okay. Now, first thing we need is LangChain. So we have to install quiet upgrade and then we just say LangChain. So I want to install LangChain as the framework because I'm gonna use LangChain. Yeah. Now with LangChain, we are going to use a couple of LLM models. Yeah. We are going to use a couple of LLM models. Now, what are those models we'll be using is a Gemini based model or a Grok based model. Why? These are two free available models given to us. So Google Gen AI, which is a Gemini based model, or a LangChain Grok model. Right? Grok is going to give us the API key or the access for us. Okay. So these are some of the basic things that I am requiring. Now, along with this, what I'll do, let me run this. Let me install this framework. Okay. I know initially I'm just taking it a little slow, but we'll quickly speed it up. So this is the LangChain framework installed and a LangChain integration because I want to use the Gemini based LLM, which is Gemini Flash 1.5 or 2.5 or 3, any of that. And within LangChain Grok, I will use a GPT model, right? Like example, these are the frameworks, right? Just like how I have a Perplexity, how I have a LangChain, how I have Claude, I can do that. For example, I wanted to use Claude's LLM. So I can just put, sorry, hold on. Yeah. For example, I wanted to use Claude. I can just put LangChain hyphen, I think it's Anthropic that I have to install. Now, how do I know this? From where do I get this? I go to the models, right? Within the models, I go to this Anthropic. Yeah. And then I look at pip install. So it says LangChain OpenAI, LangChain Anthropic. Yeah. LangChain Google Gen AI. Yeah. So I just use the LangChain hyphen Anthropic. It can be put either in this way or it can be put just by using a hyphen as well. So this now installs Anthropic as well. And then I can use any of the Claude based models also. So about 13 MB taken for that. Okay. So now if I wanted a Claude LLM, and if I wanted to utilize Claude within this, I can do that. Yeah. So what's this first step? Invoke LLM to get responses in our Python environment. See, we have been asking questions to an LLM where I think this you all know. So I go to a chat GPT and I'm asking question to a chat GPT model, anything, any question. What is an AI agent? I can ask it this question. Okay. So it's giving me the responses. Yeah. Suppose I actually wanted this same question within my Python framework. Why? Because I want to think like a developer and I'm building an agent. Yeah. Then I need to make use of a API call of that model. Which model? Of the LLM. Which LLM? Depends, whatever you are choosing. So right now you can see Gemini and Grok provides you with limited but free access to the LLM APIs. Now, if I take ChatGPT's OpenAI's API, it does not give me a free access. It is a paid credit. But if I take Gemini, I get free. If I take Grok, also I get free. Up to an extent, I wouldn't say 100%. You cannot get every answer free. But for us to build agents to use with LangChain, right? So it gives you free access. Okay, make sense? So now what is our job? Figure out what the API is, connect that LLM within LangChain, get the same response that we just saw from ChatGPT or any other similar interface of an LLM. Yeah, get the response, and then further we can utilize this. Understood? That's the first thing. Before we go into a agent building, first we need to know how to use a LLM within Python, right? So quickly what I'll do, I will go to Gemini, but not directly gemini.google.com, right? So this is the user interface, right? One thing you need to understand, this is just a UI. You can ask any questions here. Gemini.google.com, chatgpt.com, claude.ai, anywhere, right? So you are asking questions on their interface. If you want to utilize it within Python, then you need to go to the developer mode. So I just go to the AI Studio of Gemini, because in that I get API keys. Okay. In that I get a API key. You can see this is Google's AI Studio. I have an API key option that I can get. I already have an API key that I'm using. So I can take this. So take this API key. Yeah. Look, I have an API key. What you need to do is you need to create an API key. Okay. You need to create an API key. So I already sort of have one. Called it as Gemini underscore API underscore key, this one. And you choose a project. Now, some cases, some of you don't have a project here. So you go ahead and you import a project. You can import a Gemini project here. If it is not there, most of the times it is there. But if someone does not have a project, you can create or import a new project rather. Go to projects, import a new project. Okay. This is the first step that every one of you should do if you want to do agent building with Python. You need to have an API. It doesn't matter which, right? It doesn't matter if you're doing it on Gemini, if you're doing it on Claude, you do it on Perplexity, you do it on ChatGPT, you do it on Grok or any other thing. You need an API access to call the LLM. Okay. Whichever is supported on LangChain, you need that model's API and the API key. Okay. So here I'm looking at, go back. I'm looking at the API key. So once the project is ready, I created an API key, just named it Gemini API key. And now I have an API key. Name is this, key is this. So let me do one thing. I will take this as Gemini API underscore key. Okay. Equals. Copy this key. Paste it here. There are different ways to store a key. So this is stored directly. Now, if I give you this key, you can access my key. So it's very, very important that you do not share your keys. Yeah. It's very important that you don't reveal your keys to others. You do not share your keys to others. I'll tell you what happens. Now see, you all can see this key, right? You all can see this API key, right? And this is a free key. It doesn't matter, right? But if you have this key and you use this key in your own codes, you are utilizing my API key to get responses. So think about it. If this was an OpenAI key instead of a Gemini key, yeah, what would happen? You are using OpenAI key, you are using my key, and if you ask a question, if you write the same code on your notebook and you ask a question, what would happen? You are utilizing my key, you are utilizing my credits as well. Okay, there is no separate password or username for this. It is just a key, right? If you have access to a key, you can get the access or capabilities of the entire LLM here. Think about it. Someone happened. Okay. Okay, attendance and feedback link. Sure. Thanks, Sushmita will be there in a few minutes to answer those questions. Sure. Yeah. Support team will have a look at it. They should be giving you proper clarity. I think they did mention it earlier. Let's see. Okay, are you all able to follow with me? Can you please get a quick confirmation here? Okay, 1, 2, 3, 4. Come on, 280 people. I would need at least 250 answers here with a yes. Or a no is also fine if you're not able to follow. Look, what I would suggest is, if you're not able to do it practically here, absolutely no problem, since we have limited time, right? So you can always go back, listen, make notes now, follow the steps. You can always go back and implement all of these. Yes. Yeah. Okay, perfect. A few responses we did get saying yes. Okay, just hovering back. First step, you need an API key, but also make sure do not reveal this key. So right now, me revealing this key is a risk that any one of you can use this key and ask questions to the LLM. So how is it a risk? It is only that you are utilizing the amount or the credits available. Yes, that's the only thing that you can do. Correct? My credits will be utilized. Okay, now that I have a Gemini API key, done. If I go to some other API key, for example, I now go to Grok. So this is Grok Cloud. I can get API key here as well. Okay. Yeah. So Grok has this again for the API keys. You can see I have 2 keys. I have utilized this. Yes. Yes. Okay. Yes, we can store it in an environment variable. Yes, you can store it in an environment variable. Also, within this, you can see Collab has its own environment variable that you can save it. Look at this. I have saved some APIs like a Gemini API, a Grok API, a weather-based API. Yep. I have 2 or 3 APIs stored in Collab's own environment variable or environment here. So there are multiple options that you can utilize. Okay. Yeah. So if I use this, what I could do, I can directly go to Collab secrets. I can configure the code. I can save a API key here, and then I can get a value as well. Okay. Now, suppose I wanted to utilize this API key. So I can just add a new secret. I can put in the name. I can put in the key here. Okay. And then I give access. I can utilize it within the code by using a couple of lines. Okay. Now, this is a very straightforward and a direct option like this. Okay. but this is not set in a virtual environment. Okay, so we can save it in the environment as well. So this is one way. Suppose I go here, I have Gemini, I enable access to it. I have a key here, I have the name here. What I could do next is just use this code. Go here, paste the code from google.collab, import user data, and I could just be importing Gemini underscore API underscore key. And I save it in a keyword, right? Because ultimately I needed that, but it's not visible to the users in the code. Right, so this is equivalent to this, but this is a lot more secure because we are saving it in a specific environment. Okay, now that I have a Gemini API key, right? Do this or set up in a environment as well, right? Anything works. Okay, now when I just look at this, I have this ready for a Gemini API key. Now what I need to do further is, once I have this model, I need to see how this model will react. How will it work? How will it give me a response from the LLM? Now again, all of this is available in the documentation. So I go to Google, because the model is coming in from Google. Okay. And here there are two options. One is Gemini, one is Vertex. So in Google Generative AI, right, I have a LLM as the option. A chat Google Generative AI has a Gemini option. So we are using Gemini, right? What I could actually do is, I could just see here. I think this we have already installed. LangChain Google Gen AI. Yes. Further, set up with the API key. So you can use a environment, OS environment to set up like this. Enter your API key. Okay. Once the environment is done, right, how to use the model looks like this. LangChain Google Gen AI, import chat Google Gen AI. We set up the model. Isn't this the same way how we had seen earlier? Yeah. Now from this, I can extract and choose whatever are the features. Like I said, model important, API key important, every other thing is an optional parameter. So I can sort of only copy this part of it. From LangChain Google Gen AI, import chat Google Generative AI. And then within the model, I could just be extracting what is the model. Now, if you look at this, a 3.5 model is not available for free in the request. So the highest I can use is a 2.5 flash model. Okay. How do I know what are the models which are available? Right. So I can just take Gemini models. Within Gemini APIs, I have a Gemini model. Okay. Let me just go to that. Let me go down to the models. Do we have a list of the models? Let us just see here. Yes, there is 1.5 flash, 1.5 flash 001. Right, so just a couple of names in here which are available. I think going back, Gemini models list. Yeah, Google models. I think from this we can get a better list of the models. Yeah, there is 3.5 flash, 3.1 flash light. Right, so there is 3.1 flash image. Right, so this is about the nano banana. Yeah. So if you look at this, this is a complete list of all of the available Gemini models. Yes, are you understanding? Now, how did I choose this? It's because only this is available for free for us to use. Yep. Any other things, it does not have that limit available. So I can use up to 2.5 flash. Yep. 3.1, 3.1 Pro, 3 flash, all of that might not be giving us the access from this API because those go under the paid API source. Okay. So some embedding models also we will be using. Right? So those are also available for free. Okay. Now, once I have a look at it, you can see these are all the models. I will choose the Gemini 2.5 Flash. Okay. Now, in the free cloud API tiers, right, LangChain allows us integrations with Gemini, Grok, Hugging Face, 3 of them. Okay. Any other thing is a paid resource, right, in terms of the LLMs. Yep. So now in the name for 2.5 Flash, this is the model ID. Everywhere we need to copy the model ID, paste it here, which is Gemini 2.5 Flash. Okay. And the next thing that I'm expected to do here is to put the Google underscore API underscore key. So I'm passing on the Google API key, right, which is saved in Gemini underscore API underscore key. So that is my Gemini LLM initiated or setup. Here's the key. Are we understanding this? So you set up your key, upload it here. You set up LangChain, Google GenAI, right? And this is how you set up your LLM. I have set up a Gemini LLM. Now my only step remaining is Gemini underscore LLM. How do I invoke this? I'm asking a question, right? So this is the same version where I go to Gemini. Yeah. Where I go to Gemini, it is same as this. Yes, don't worry. The file will be shared. The file will be shared. You need not worry if you're not having the code yet. The code will be shared with you. The entire document will be shared. Don't worry. Okay. See, asking a question, what is agentic AI? Or explain multi-agent orchestration. And 5 sentences. Yeah, and me choosing a model. Right now, I think only 3.5 Flash can be chosen. Or 3.1 Pro. I cannot choose a lower model. So asking this question here is equivalent to asking the same question here with the Gemini.invoke, but this by using an API. Okay. Look, we are just getting this here. So it's now giving me the answers. Okay, in terms of the limits for the Grok LLM, right, I think we have enough. About 12,000 plus requests. You will actually have a limit request per day within Grok. But the problem comes wherein if you have tokens, right, particular amount of tokens, there is a limit per day. Okay, based on that, it will be there. Yes, now that I've done this Gemini.invoke, right, so maybe I can just ask it to be printing only this. Right, so then I ask all of the questions for this, printing the responses here. Okay. If you see here, how many tokens are utilized, right? How many tokens are actually utilized in here? Look at this. I have input tokens 10, output tokens 371, which is almost like 5-6 sentences. So it gives us a total of about 381 tokens, right? Input, output, but in the output, it has got a lot of reasoning tokens as well, based on 253 tokens. And the name of the model used is Gemini 2.5 Flash. Model provider coming in from Google GenAI. Yeah. Are you all understanding how this works? You get the access, you ask questions. Now, if I give a print, only the content will be displayed without any of the details of the tokens and everything. We're just getting the direct answers here. Okay, now it's just giving us the content, but it is displaying it everything. Okay, there is token details as well. But yeah, it displays it like this. Hope that makes sense. This is how we have the LLM invoke in here. I can do the same exact thing with Grok. See, as you know, I've already installed the Grok LangChain framework. LangChain-Grok is also there. So I only need to use this line, set up the API key, ask the question by using a Grok LLM. Correct? One moment. Okay. So if I look at this, similar to the Gemini API key, I go to the secrets. I add a new secret. I add a Grok API key, which I take from this. Now, this is a one-time use. So if I go edit, I don't have the key. If I want to use this, I have to create a new one. But I have already saved it. So if you are creating it first time, you can create a new API key on the Grok console. Yeah. So I have a Grok API key here with the key available and saved in this. Okay. So I can just enable this, use the same code to access the secret key. Right? How do I do that? I go to this. I set it up here. Yeah. Once I set this up here, so I can just use Grok API key, and then I can extract this as Grok underscore API underscore key. Getting it? I'm getting a Grok underscore API underscore. Okay, so now if I look at this, I have got a Grok LLM. Yeah. Okay, so I've got a Grok LLM, a Grok API key initialized. So then I look for the code within this. Yes, I will tell you what is the difference. Just give me a minute. Yeah. So in the models, I go to a Grok model. Yeah. I need this interface. See, installation wise, LangChain-Grok is already installed. Model wise, we import Grok and then we can take whatever is the model. So same parameters, or I wouldn't say same, similar parameters. From LangChain underscore Grok, import chat Grok. Here it is LangChain Google GenAI, import chat Google GenAI. Okay. Next step, LLM. So here I call this as Grok LLM. I am naming it. Equals to. There it was chat Google generative AI. Here it is chat Grok. Model can be anything. I'm using a Quen model. In this, that is the default. But instead, Within this, within the Grok, I have a different model available as well. So if I look at Grok models and the list which are available, there is a GPT OSS free model that I can use. There is Quen, Llama, GPT, so many models are available. Yeah, but I will be using a reasoning OpenAI GPT OSS 20B as the model. Okay, so I can use any of these. Yeah, so I use this here. These are extra other parameters. Temperature, right? I'll keep temperature. Max number of tokens, you can set a limit if required. If you have a limit constraint of your tokens, you only want outputs within these many tokens, you can do that. Timeout, retries, all of that we can change. But we'll put only this much. Okay, for our clarity. I have now invoked the LLM. Temperature 0 is the default. Okay, so Grok LLM is that here. Okay, I think we need to give the API key as well. Yeah, we missed that. API key equals Grok underscore API underscore key is the key that I have taken. So name of the model API key. This is additional. Here we have the Grok LLM. Now I give the same question. I ask print. And then I say Grok underscore LLM dot invoke of. Example, what is Agentic AI is my question. So it'll give me all of the questions, all of the answers or the content. If I specifically want to extract the content, I can get the response here like this. Yeah, beautifying it or extracting only the answers correctly. So now I've got the response from the Grok LLM. Are you understanding? Any specific differences between Grok LLM and Gemini LLM? The answer for this is how good is the Gemini model versus how good is the GPT OSS OpenAI model which Grok is providing, right? Now you tell me, in the LLMs, you use ChatGPT, you use Claude, right? And you use Gemini. Which model do you think you prefer to use? Which is the best model currently available in the free version? Yep. The same models are utilized here. It is that answer. Yeah. But the thing is, currently GPT is using a GPT 5.5 version. Gemini is using a 3.5 flash version. Claude uses a Claude Opus or Claude Sonnet. So depending on your requirement, whichever is the best model, you can choose that. Also, those are paid. The APIs for those are paid. So if you pay, then you can choose whichever is the best model. Accordingly, you can take this. Now, in the free versions, we do not have much choice. Yes. Grok gives us a couple of models. We can use only those like Llama, Quen, Llama, and GPT. So we can use only these. Correct? Gemini has a couple of models. We can only use those. Those are the freely available ones. Otherwise, we have to pay. So if you pay, you can get any of these models available for you. Getting the point? So this is just a medium, just an interface to connect that, to implement that, get answers within the Python environment. List of free models is just this. You have Llama, you have Quen, you have GPT, OSS. Okay. Then there is Gemini up to 2.5 flash. Anything lower than that is going to work. Gemini 2.5 flash. Yeah, few versions in Llama, few versions in Quen. It's not Owen, it's Quen. These are some of the freely available models within this for the integration. Now, there may be a few other options as well, but these are the suggested ones. These are the recommended ones. Wherever I have seen, these are the ones that were available for free. Yeah, with decent amount of rate limits. Claude is not. I haven't tried with the API of Claude, but I've heard it's not free for the API usage within this. See, we might as well give it a try. There are so many LLMs, right? Now, these are the common ones available for everyone without any problems. So I generally show these. There are so many. Maybe there is some version of Perplexity which is free, some version of Claude which is free. So we have to explore every version of it. So that is up for exploration. I think now I've given you a platform as to how you can get those questions, how you can set it up, how you can ask. All you need is API and few of these codes. And then your invoke should give you the answer. If same question is provided to multiple models, can you generate a new response based on all responses? You will have to do that manually, which means take that, feed that in, and then you will have to take that as another, what do you say, question as a prompt to the LLM, then get a better answer. You have to do that much. Okay. Okay. Right. Shall we continue into the RAG option or RAG based questions implementation for that? Okay. Um, how to connect this to client? Which client? You can use this. You can build a, what do you say, app based on this. You can just use or implement this LLM, build an app, which will just look exactly like the app that we get from this. So you can replicate something like this. You want your own version of Gemini, Google, this app. You can create all of the features, implement this code, and via API, you can build your own Gemini, right? You are using Gemini's API, but the interface can look different and you are doing API calls. So there will be that limit that you get. Yeah, about how many? 14, 12,000 plus requests in a day. Getting it? Now, how you design the app is completely on us. We can use any of the frameworks, use HTML, Node.js, use only Python based, use Django based framework, use fast API based framework, use Streamlit, the example that I was showing, use, there is one more thing. Yeah, you can use any of those kind of frameworks to build your own app. Okay, there's Gradio. Yeah, you can use Gradio also. Those are the examples. Okay. Now we will now go to a RAG based agent or a RAG based system. Yeah. Now, in LLMs, there's one thing called as a LLM hallucination. Your models, it's not necessary that it gives you accurate responses. Okay, your model can give you wrong responses. I think this we have seen. It makes mistakes. Gemini model, ChatGPT model, any model makes mistakes, and it now they even mention everything, saying that it can make mistakes. Beware. Correct. So that is called as a LLM hallucination. It can give you incorrect answers or fabricated answers. Just a minute. Let me just put this to charge. 1 minute, right? Yeah, I was saying that any LLM can give you incorrect responses. It can give you fabricated responses. Yeah. Which means it can hallucinate. What happens when an LLM hallucinates? It gives you incorrect responses. Yeah. And that can be a problem. Why? Because whatever answers you were expecting, it's not giving you those answers. Yep. Also, whenever you have a requirement saying that I want to access and ask or get questions only based on certain data, only based on certain PDF, or only based on a certain document, an Excel file or anything. Yeah. In that case also, it's a problem. Primarily to reduce hallucinations, there are multiple techniques. RAG-based system is the first one, where you give additional external file that you connect. Or you have output verification, and you enforce predefined output schemas initially. You set up proper expectations or details. Yeah. Or there is a human in the loop system, where you review. You ask it for an automation, but then you review everything. Can also be done. Okay. So we are discussing the aspect of using a RAG-based system in here, wherein your retrieval system, as of now, we have done this. You ask a question to the model or the LLM, it will give you the answer. This one we have implemented. But what if I wanted an external file, like a PDF or an Excel or a Word document additionally, and I wanted the LLM model to only answer from that question or from that document? Yeah, makes sense? Can you do that? Is this possible right now without any of these Python-based, LangChain-based framework? Can you do this right now? That you want to ask some question only based on the, what do you say, PDF or the Word file. Will it work? In the free versions. Google LLM. Okay, saying Gemini. Okay. That's right. Notebook LM is a RAG-based system. Completely. Notebook LM is exactly the implementation of a RAG-based system. Yeah. Notebook LM is a very essential, very useful tool. I can agree. Yeah. But if you wanted to create a own, what do you say, version of Notebook LM, a RAG-based system, again, Notebook LM is a ready-made UI. It is already available. Everything is there in that. It is like Gemini. Can you use it for developer purpose for your own work? As a developer, I don't think you can, because you cannot customize it to look like how you want your own app to be. Correct? So if you want to think it from a developer perspective, where you want to embed all of these things within your own app, right? So you have to create your own RAG-based system, exactly like how Notebook LM looks like. We can create our own system. Okay. Now, Notebook LM is a ready-to-use application, but there are about 6-7 steps that are there within it that is not really shown. We are using it as end users, but thinking from a person who wants to develop, who wants to build an agent or create a system, so then that cannot be used. Yeah. So RAG-based system exactly shows us the same thing, but via code, via a LangChain integration, by using the same LLMs. Okay. So RAG system has two parts: indexing and then retrieval and generation. Indexing is where you take the data ingestion. Retrieval and generation is the RAG chain. It takes the questions, takes the data, and it matches, and then it gives you the responses. Okay, that's how a RAG-based system works. So there is a complete, what do you say, path. This is for indexing, how to load the data. Loads the data, it splits it into chunks. Then it creates a vector version of all of those, and then it saves it into a vector store by using certain embeddings. This is your first indexing step. Once you have the data, data can be anything: PDF, Word, image, JSON, anything, video, whatever. All of those sources, it will take the data, it will split the data by using splitters. Then it will convert that data into vectors, use vector embeddings, store it into a vector database. The first initial step of RAG. After taking all of that, it will retrieve answers from this vector store. When I ask a question, it will retrieve answers from this vector store by the use of an LLM and then give us a response. So that is a good 5-6 steps implementation which is available for a RAG-based system. Okay. These are the steps. You load, you split, you use embeddings, convert to vectors, save it here, you retrieve that data, then a prompt comes. Based on all of this data which is retrieved from that, it will ask you a question, you give the answer by the use of an LLM. Yeah. So this is the RAG-based system that we can implement here. Make sense? Understand it? Yeah. So I can show you a code which is ready for this. Right? I know all of these codes are line by line implementations. I do have the code. I can show you that. Right? But those are the line by line implementations wherein we use the LLM, we load the file. Yeah. After that, we are going to individually split. See, loaders can be anything. And I'll just show you here. What are the options? Loaders. Right? Document loaders can be, I can load a PDF. Yeah. I can load an Excel file. Yeah. I can load a Word file. I can load a JSON file. What else? I can load an image. Yeah, I can load a video. What else? What are the types of data? Word, Excel. Yeah, maybe even a PPT can be tried and loaded. All of these files are loaded here by using a LangChain document loader. Once you load that, there will be 2-3 steps. You import some library, you write some codes, and then you can load it. Once that is done, it will do the pre-processing. If it is images, how to pre-process that. If it is text splitter, it will split all of that data into chunks. Because we have tokens, there is a limit for tokens. And we also have the context window, if you remember. Yes. Because of that, the splitters are necessary. So what it does is, if there is 10 pages, it will split that 10 pages into maybe like half page each as one chunk, or 1 page each as one chunk. Yeah, then it will create 10 such chunks. Okay, that is what a text splitter does. Split your data into chunks. Okay. So we split the data into chunks based on tokens. This is a very important step in the RAG chain. So even if you give your data to Notebook LM or any similar RAG-based system, right, what happens? It will have to split your data into chunks. Okay. The loader, the splitter, the pre-processing, all of that thing is supposed to happen. Okay. Without that, you cannot have a RAG system. Now see, I've got some paragraphs from this, correct? After I do the splitting. Once I got those paragraphs, what do I do? Like we had seen here, once the split is done, I then embed it. Okay. Good. That is the next step. Embed it, convert it into vectors. How chunk is decided? There are various types of splitters which are actually available. Right? I will in brief show you that as well. Yeah, in fact, I actually wanted to show you the entire code with its implementation. But unfortunately for this thing, we cannot. I can just show you the ready code. See, if I go to the text splitters, Yeah, we have a LangChain text splitter. Splits or breaks larger document into smaller chunks, which will be retrievable and fit within the model context window limit. This is a very important thing that we need to know. Okay. So there are different types of splitters. You can choose whichever one you want. Length based is one type. Text structure based is another type. Yeah. And the third type is document structure based. Text structure based, length based, document structure based. If you have a HTML, Markdown, JSON, then you use the document structure based splitting. If you want to split by tokens or characters, you use a length based splitter. Right? It is called as character text splitter. You can just use this. There are some names and encoder names which are available based on tokens. I can put whatever number I want, the chunk size. One more is text structure based. This is the most common one that we use. So if you want text that it should be broken into chunks based on paragraphs or sentences, then I can use a text structure based splitter. So there is something called as a recursive character text splitter. You can decide what is the size of the chunk. We generally put about 400 or 500 as the chunk size, 500 tokens. So for 10 pages, I think it comes around 32 splits will be there, or 32 chunks will be there for the tokens. Okay. Now this is up to us. I can choose whatever I wish LangChain will accept. And it will just go ahead and proceed to the chunking according to my requirement. Okay. Yeah. Heading back. What do we do after we get the chunks? These chunks are going to be creating embeddings for us, vector embeddings, right? It will create this data as vectors. Why? Because computers cannot understand text. It needs to convert that into a vector. It needs to convert that into a number. But if I just put 0, 1, 2, 3 for a sentence, there won't be a meaning for that word, because later I have to embed it. I have to also decrypt it again. So it is almost like the encryption decryption. So you take original data, you encrypt it with a key. And then further, you are also going to decrypt it with the key. Correct? Have you seen this encryption and decryption? Same things. Here you embed it, then you retrieve it. Now, while you do the embedding, it is very important for us that we don't lose meaning of the words. We don't lose meaning of the sentences. Yeah. It's quite important for us to take that. Embedding, right? Again, for that, we need a model. Gemini has some model that we can use for embeddings. A lot of them have the different models for embeddings. We generally use a Gemini embedding model. Okay. Now, once embedding is done, we save that data into a vector store. Okay. So I'll just show you first the embedding system. Yeah, this thing. Embedding means it converts text into a list of vectors that capture the semantic meaning of the sentence. For example, the cat is sleeping and a kitten is resting are two sentences. You look at the meanings of this. So it understands based on these similarity numbers, 0.23, 0.21. Similar, it places here. Okay. So it places this word the here, it places a here. Both are very close to each other, 0.23, 0.21. Now it takes sleeping, resting. It places sleeping and resting as two words here, 0.78, 0.80. These are the embeddings which are generated, vectors. Then one more, is, right? Two slight different vectors available for the same word because they are in different context. So it saves this 0.05, 0.45, 0.41. These are the words. So the next time, because the meanings are similar, vectors will be close together in the vector space. So the next time when we are retrieving, if I ask the question, right, kitten is sleeping, so it should understand that it is the same thing. Both are very similar and it will retrieve one of the answers from that and it will give me the answer. This is what embedding does. This is how the embeddings are created. Then it will get stored in a vector store. It will get stored in a vector store. Example of a vector store is like ChromaDB, FAS from Facebook AI similarity search. You all know databases, right? Examples of databases: MySQL, PostgreSQL, MongoDB, all of that. Similarly, we have a vector database. So in terms of a vector database, we are looking at ChromaDB, FAS, Pinecone. In fact, even MongoDB to an extent can be used as a vector database, vector stores. Okay. It stores everything there. So our first indexing part is done. Then the retriever part, retrievers RAG. Okay. This is the RAG pipeline. Yes. Indexing is done, retrieval, augmented, generation. So whatever is the relevant information, it will be retrieved. It will be added along with the prompt, and then we get the final answer. That is how the RAG system works. Okay. See, I think about embeddings we saw. Vector embeddings converts words into numbers. Okay. Vector store is that vector database that we save our data into. Yeah. Example is FAS. FAS is a vector embedding. Okay. Augmentation is just attaching the data onto the LLM's prompt. Context, whatever we receive, right, or whatever we retrieve from the document, that context we add it along with the LLM prompt saying this data. That itself is augmentation. What is augmentation? Adding, connecting. Yes. Attaching. That's the same thing. So it attaches the retrieved information which is coming in from the document that we have applied to the prompt. So that retrieved data plus prompt, whatever answer we get is the RAG based answer, which is what happens in NotebookLM. Yes. You ask a prompt, first you upload some source. From that source, you ask a question, it will give you the answers. You ask anything outside of the source, it will not respond. It will say probably like, I do not have any knowledge about this, or it is not in the source. Correct? So those are the steps that we have here. Yeah. And any questions? This is how you create a RAG-based system. Any questions? Are you all understanding? Is it clear? Yeah. I will show you a code which will just give us the entire thing. One moment. No, just a minute. I'm just showing you the code for whatever we have just tried to set up here. One moment, I'm just sharing my screen. Okay. So we are done up to the invoke part. Now, in terms of a RAG-based agent, right, as you can just see, we install certain dependencies like GenAI, Grok, anyways, these are all installed. Right, so there's like LangChain community, text splitter, and I have just created only for PDF loading. Right, for example, I say I want to load a PDF of this file. So I create a loader. Now, once it is loaded, I use that splitter to split the document. Once that is split, I use the embeddings. Yeah, I'm using that option to create the embeddings. Correct. So what it does, it is just taking all of those things. Not this, sorry. This one. Yeah, it is just taking all of those data, right? It is creating a vector embedding for that, right? Then further what I can do, I can save all of that in a vector store. Correct. So from whatever is the embedding that I have got, you can see it is a Gemini embedding model. I can save that into a vector store called PAS. See, a Gemini embedding model with the same API key that I need to take. Then I save that in FIS. FIS is another vector store. Yeah. From the vector store, I create a retriever. Okay. So once I have a retriever, it is now creating a retriever, which is my next step. So further from the retriever, I have finished the indexing part. Retriever is done, right? And then I'm just going to create a chain, a RAG-based chain. So if I create a RAG-based chain, which is the step 5, right? LangChain chains. So I say this is the LLM, this is the retriever, and then from this, I want you to give me a answer the moment I am asking a question. So I ask a question, and then it will give me all of the details about that document. What is this document about? It will give me the results of that document. Okay. So this is exactly the RAG-based implementation. But this step can change. Like I told you, this is only for a PDF. If I wanted a different loader, I have LangChain, which allows me to use different document loaders. So I can just look at this. Document loaders, there are so many options, right? I want unstructured data. I want a document from any web page. I want a PDF, right? I want data from some common file types. Yeah, most of the file types are there here. Unstructured, doclink. Yeah, and all of the list, any of the document loader from any of the source I want. Yeah, I can just take that and I can just implement it here. Instead of this step, any other loader can come. That's all. Are you getting it? This is your RAG-based implementation pipeline. This is what happens. And the result is, like you all said, what Notebook LM can do. Yeah, I will show you that tomorrow in the first place. The result for this, I also have a ready app created, right? So the same implementation, I will show you a app, a RAG-based app, and I'll give you the code for that as well, wherein you have a ready app, which will give us the output. Make sense? This is the code-wise implementation. Yeah. But on VS Code, I will show you how to run an app, or on local Python, how to build an app, how to implement it using Streamlit. I will show you that. It hardly takes 5-10 minutes. I have a code ready. You can use that, create your own versions of the RAG-based chain. Yeah. Atul, augmentation is nothing but whatever answer we get from the retriever, right? We take that, we attach it to the prompt. It does that automatically. Retriever takes the best data from the sentences which we have saved in the vector store. Yeah. So it gives us the context. That context with the prompt gives us the better answers. That's all. No, there is no cost involved in using FAIS. FAIS CPU, no cost. Okay. Yes, the notes will be shared in the LMS, the PPT, and this file as well, the collab file as well. Okay. PPT will just be like a PDF reference for you. But this is something that you can take, you can edit, you can write your own code. Yeah, that is just for your reference. But you'll get this collab notes as well. Okay. And any other questions? Yeah, on a very similar note, our next agent will be created. If we know how to do these steps, most of the things in the next steps will be easy for us. Yeah, maybe in a couple of hours, you should have your collab notes also with you, the collab file as well. It is a notebook file, an IPYNB. You can take copy in your own notebooks. You can feel free to edit it. Okay, we'll stop here then. Yes, okay, all right. If that's the case, we'll stop here. We'll come back tomorrow and continue. Thank you all. Thanks for joining. See you tomorrow.
Thank you, sir. Thank you all for joining. We'll meet again by tomorrow.